Bismillah ar-Rahman ar-Rahim. My name is Dr. Ahmad Azzazi at the Applied Science University at the Faculty of Information Technology. As a part of the open course system, I would like to give the part number 4 of the course Computer Organization and Architecture with the title Computer Evolution and Performance, part number 3. This is the prerequisite for the course, Digital Logic. This is the course description. This is the textbook, and this is the reference for the textbook. Okay, we will talk now about the IBM 360 series. It was introduced in the year 1964, replaced but not compatible with the 7000 series. It was the first planned family of computers to have similar or identical instruction set and similar or identical operating system. It has an increasing speed, increasing number of input-output ports, more terminals to use as IOs, increased memory size. Also, it was with an increased cost associated. The DIC P8, it was from the Digital Equipment Corporation in the year 1964. It was the first microcomputer, did not need air-conditioned rooms, small enough to sit on a lap bench. It was about $16,000 US, the cost for it, compared with 100,000 plus 100,000 for IBM 360. It has an embedded applications with a bus structure. This is the bus structure of it. It was called an omnibus, connecting all the different I/O modules and the main memory with the CPU and with a console controller. We will talk now about the semiconductor memory. In the year 1970, the company Fairchild produced a size of a single core memory with 1 bit of magnetic core storage, holding 256 bits. It was a non-destructive read, much faster memory or capacity, approximately doubles each year for the memory sizes. We'll talk now about the Intel company. It is a major player in the field of producing microprocessors and CPUs. In the year 71, they produced the first microprocessor called 4004. All CPU components were placed on a single chip. It was a 4-bit CPU, followed in the year 72 by 8008 processor. It was 8-bit, both designed for specific application, the 4004 and the 8008. In the year 74, they introduced the famous 8080. It was the Intel's first general purpose microprocessor. We are dealing with the speed, how we are speeding up our CPUs through pipelining, through the usage of cache within the CPU and within the board. We know that we have the level 1 cache and level 2 cache. We could use branch prediction, data flow analysis, and speculative execution on the CPU. For the performance balance of all of these things, we have a processor. The processor speed increased with the time. We have a memory with a capacity increasing with the time, but memory speed lags behind processor speed. Therefore, we are seeking to balance all of these elements together. We have a logic and memory performance gap. Logic, we are meaning with the logic the performance of the CPU speed, and memory speed. We have a lag between the CPU and the memory speed. Therefore, we are looking for a performance balance to overcome this problem. Solution: increase number of bits retrieved at one time, make DRAM wider than deeper, change DRAM interface, use a cache, reduce frequency of memory access, more complex cache and cache on a chip, increase interconnection bandwidth, high speed buses, and hierarchy of buses. We have also the I/O devices within the computer organization, peripherals with intensive I/O demands, large data throughput demands. Processors can handle this. We have many solutions to handle I/Os, like caching, buffering, high-speed interconnection buses, more elaborate bus structure, and multiple processor configurations. The typical I/O data device transfer rates differs between the different I/O types. The slowest type is the keyboard. It is less than 100 bit per second. The mouse is over 100 bit per second data rate. We have then the hard disk increasing data bit rates. It is about 100 mega bit per second. The giga bit Ethernet is one of the fastest I/O devices. It is about 1 gigabit per second. Also, I would like to mention the USB. Okay.